Hello everyone, this is Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking quick about binomial coefficients. Let's start with an example here quickly. 8 people run in a race, there's no ties, and if the top 3 finishers advance to the next round, how many different groups can advance? Now, this may remind you of the permutations and factorials video as well. I will link that in the description below. But if we were doing this with order, right, so we had a gold, silver, and bronze medalist in that race, we might remember the answer as 8 factorial divided by 5 factorial. Right, we have 3 finishers. This, of course, simplifies to 8 times 7 times 6. And right, we were picking them in order. So 8 choices, 7 choices, 6 choices, and we can write this pretty nicely as a factorial as well. How is this one different though? Well, if we just want the different groups that can advance, right? This is our key difference. We don't care about who got first, who got second, who got third. We just care about the groups, meaning we don't care about the different ways we can shuffle those first 3 people. They're just a group of 3, so we also need to divide this by 3 factorial. Think about how many ways 3 people could finish a race, right? 3, 2, 1, there. So when the dust settles, we can cancel the 3 times 2 and the 6. We're just going to get 8 times 7, which is 56 in this case. Now, again, this is always part of a bigger kind of example, a bigger problem that is asked over and over. So the general question here is we have k different objects. They're chosen in no particular order from a collection of n total objects. How many ways can this happen? And here we want to introduce some notation as well. So we have the number of ways this can happen. Our answer here on the right side should not surprise us. There's n factorial total objects. We have to divide by n minus k like in the permutation. And now we have this extra k factorial as well. Now notationally, this is equal to this symbol right here. So it's like a fraction in parentheses, but no bar in the middle. And this is usually referred to as, or you were talked about this as n choose k. There are n choose k ways to pick these objects. Now, you probably can guess this is actually what is called a binomial coefficient. And in some upcoming Thursday tidbits, we'll talk a little bit more about binomial coefficients and where that name comes from. But this is that notation. This n choose k notation is what could be used for this type of problem with no order, which is often called a combination. So you will have permutations with order, combinations without order, and when we're doing these combination problems, you can quickly answer them using these binomial coefficients, n choose k type of notation. Let's see one final kind of actual example here where we're kind of solving a slightly more interesting question. So the Lakers and Celtics play a 7-game series. If the Lakers win the series in the last game, how many different ways can the series play out in that case? So 7-game series, that means it's the first to 4 wins, right? So you need to get 4 wins. 4 out of 7 means you won the series. And so if the Lakers win the series in the last game, this actually tells us a couple of things, right? So first of all, it definitely tells us that this last game has to be won by the Lakers. And let's just use an L there to stand for Lakers. So Lakers win the last game, and then there are 6 remaining games there. But let's think about these 6 remaining games there in that case. So there are 6 spots in total, right? So we have 6 spots. And what has to happen for those 6 spots? Well, the Lakers have to win 3 of those games, because remember, it's 7-game series. They have to win 3 in total, right? So this is going to be 3 places for the L's. So 3 L's in that case. Why is it enough to just pick where the L's go? Because the other spots go to the C's, go to the Celtics. So all we have to do, right, let's just do one example quick. You could pick, okay, the Lakers win those 3 games, and therefore the Celtics win the other 3 games there. So, right, you really just have to pick where those 3 spots for the L's will go. Now, are those L's in any particular order? No, because if the Lakers win the first, the third, and the 5th game, that's the same as winning the 5th, the third, and the first game. So lo and behold, this can be answered with our binomial coefficient. There are 6 total spots. We need 3 of them. Those 3 are in no particular order because they're all L's. So this is 6 choose 3, writing this in terms of factorials. 6 factorial over 3 factorial, 3 factorial. And if you simplify this, right, 6, 5, 4, 3, 2, 1 divided by a couple of 6's in that case, this will actually simplify to 5 times 4, which is 20. So there are actually 20 different ways this series could play out. Thank you guys for watching this video. Check back each Thursday for a new math tidbit. And thank you guys for watching, and I will see you all next week. Goodbye.